Hello everyone, welcome back for another video in our best practices storage architecture series we've been doing. In our first video that we shot, we spoke very high level and architecturally about the best practice concepts for dealing with your storage architecture. Mainly we focused that around not the technology, but more around the various perils that you face when it comes to keeping your data safe. These perils include hardware failure of drives, of pieces like that, of accidental deletion or data corruption, of viruses attacking your files and crypto-locking them, or bad actors attacking your server and getting in where they shouldn't, or the big scary one, the flood, the fire, the meteor attack on the storage. And what we wanted to present with that first video was the idea of you should pick your storage technologies and solutions around solving those perils, keeping your data safe. But very high level, very architectural, we're at a whiteboard and more hand waving than actual work. So what we're going to do in the next series of videos, or the next set of videos we're going to do here, we're going to break down each of those perils and how you can use a 45Drive storage server, the Houston UI, and you can bring yourself up to be ready to protect against all of those. Okay, so for today's video, we're going to be talking about protecting against malicious deletions or accidental deletions and data corruption using snapshots. So let's get into it. Okay, so the two perils that we're going to dive into, like I said, we're going to look at data corruption and how to protect that, and then we're going to look at data deletion, both accidental and intentional deletes. We're going to go into Houston. I'm going to show you how you can combat these things. But quick refresher, what are both of them? What are the things we got to worry about? Let's first start with data corruption, or I like to call it silent data corruption. It's the kind of stuff that, like, you go to read a file back, a picture, an Excel file, a doc, whatever, and everyone's seen it. You click on it, and then it just kind of gives you that message of being like, corrupt file, or I can't read this file, or whatever. And you're like, what happened? Sometimes what can happen on disk, remember, when everything's stored in a storage array, at the end of the day, it's all stored as ones or zeros. And those bits sometimes can flip. There's numerous reasons why this can happen. My favorite one to talk about is the cosmic rays. No word of a lie, like highly energized particles from space can actually flip a bit. There's a whole other side story about, anyway, I won't get into that right now, I'm sorry. But data corruption, it happens, it can happen, and it can quietly break your data, even though your RAID array is perfectly fine. So how do you combat this? Well, you're gonna wanna use a file system or just a storage solution that that implements copy on write, because that way it allows you to do checksuming. It allows you to keep a record of a little, how would you say, a signature for the file, and every once in a while you can go through and you can scrub it, see what the sig of the file is, and if it doesn't match, well, we know something must have got corrupted there, and it can rebuild the broken parts based on the parity of the disk. So how do you protect against data corruption? Well, you use a software-defined solution, use a copy on write file system, and something that can support checksumming and the correction of quiet data corruption. Okay, so before we dive into Houston to show you how to do your scrubs to correct against that, let me talk about our other peril that we're going to get in there and look at too, data deletion. So both accidental deletion and intentional deletion. So what do I mean by that? Everyone's deleted a file by accident you didn't want to delete, or you changed something you didn't mean to change, you click save and you went, oh shoot, what am I going to do about this? Or on the more malicious side, maybe someone in your organization is mad and they've deleted some files or they've changed some things maliciously. How are you going to get those changes back? You can restore from a backup. Sure, that might take time. Or what you can do is use snapshots. Like with our data corruption, using a file system that has copy on write underlying concepts in it, you're able to use snapshots of your data, which literally mean, actually it's one of the few things in the IT industry that's named exactly what it is. It is a point-in-time capture, picture, if you will, of your data. And what that means is if you snapshot every, say, 5 minutes, say you delete a file and you go, oh crap, I need that back. You can roll back 5 minutes and restore that version of it. Really, really helpful. Anyway, that's enough of me talking. Let's jump into Houston, and I'm going to show you how you can set up scheduled scrubs to protect against your data corruption and scheduled snapshots. So should you ever need to restore a file from you maybe clicking something you should have, or someone else maliciously getting rid of something they shouldn't have. Okay, so here we are sitting at our overview screen in Houston. So let's pop over to our ZFS tab. So I've got our active Z pool that we created in the last video. And now we want to set up some automated scrubbing on it, and we want to set up our automated snapshots. Don't worry about this second pool here that's degraded. We're running some tests on how fast it takes to rebuild hammer drives, but that's a topic for another video. If you're interested, actually, you can ask us in the comments below, because I am really interested in those things. But that's not what we're here today, and my producer's already saying shut up. So let's get back on task. Our active pool, this is what we built last time, right? Remember our 3-disk RAID Z1, and we want to set up scrubbing on this first. So we're going to pop over to the task scheduler module. So right now I don't have any tasks. Perfect. Let's create one. So we're going to add a new task, and we're going to say active Z pool scrub. You don't have to put underscores in between them. I come from the Linux world, and I hate spaces in names, so that's why I did it. You can call it whatever you want, but we want to go and grab a scrub task. Now it's going to pop up. It's going to ask us what pool. So I want to use active, and I want to hit add task. So now, do I want to schedule this task? So yes, I do. So how often do we want to run this? Well, in my case here, I want to scrub my data every day. Now, is there an implication to that? Yes, there is. If I am scrubbing data, that means it needs to check the checksum of the data, meaning that this background task is going to use some of the I/O capacity of the disk. In my case, in my use case, what I'm doing here, I am so risk adverse to my data getting silently corrupted at all that I'm okay with giving some disk I/O to a background process. But some people might have such a high performance load on their storage server that maybe they got to squeak scrubs in on a weekend or something like that, right? So that will all depend. In my case here, the scrubbing in ZFS is pretty lightweight. We've never really seen it cause such a big issue like it can in some other systems. So in my case here, I'm going to set it daily, and I'd recommend most people do the same. So we're going to say save this interval, and now we're going to hit save schedule, because at the start of the hour, at midnight, every day, every month, every year, I'm going to run it at midnight, start a scrub, keep going, do the next one. As your data gets fuller and fuller, maybe it's not done in a day to scrub it all, and then you can start spreading it out and everything. Right now, I don't have any data on this thing. So as soon as it starts coming in, scrub that thing, baby. So we're going to hit save schedule, and now it's going to start. Well, it's going to start. Task hasn't run yet because it'll kick in at midnight. So what I could do is hit run now, and now it just kicked off a scrub. And then it'll do the next one at midnight. So there we go. We've got our active scrub running. We now don't have to worry about silent data corruption in our Z pools. So the next thing I want to do is I now want to protect against the third peril. Accidental deletion, malicious deletion. I want snapshots. So where am I going to go? I'm going to stay right here in Task Scheduler again, because I don't want to make my snapshots manually. I want it to just happen. So we're going to hit add new task. This time we're going to call it active zpool snaps. And I'm going to pick automated snapshot task. Again, I'm going to pick a pool. And in this case, I'm working active. And then which data set. So here's an interesting choice. You can have multiple data sets on a pool, right? Like we talked about before. You could do it at the top level of the pool, or you could do the data set. I'm just going to use my one data set here because that's all I'm going to use. If you're going to have multiple data sets, you could have different snapshot schedules for each one if you wanted to. Or if you want, you can just snap the top level pool and everything gets snapshotted. Whatever's easier for you. In my case, I'm going to snap the individual data set on here. And now I can set a retention policy. And remember, whenever you mouse over any of these tooltips, they help you with some of these concepts of what you're trying to do. So what is the retention policy? Well, let's read it. How long to keep the snapshots for. If we leave it at 0, it'll never delete a snapshot. It'll keep it forever. So is there anything wrong with that? That sounds good to me. I'd like to keep all my snapshots forever. Well, with ZFS, it's FFS true, but mainly for ZFS here, that's essentially true in a way. One thing you hear a lot is snapshots are free. Well, what the hell does that mean? Well, they're free in the case that they take 0 resources to run. It's not like it takes time. Like if I create a snapshot, boom, I get it immediately. It's just, boom, keeps track. So, and that sounds too good to be true. Nothing in life is free. You are right on that. But remember, a snapshot just keeps track of the data that was there. So, if I took a snapshot at one point and I did not change any of the data and took another snapshot, how much space would that snapshot consume? 0, because nothing has changed. If I took a snapshot and then deleted a file and then took a new snapshot, does that consume any space? Yeah, because it's got to keep track of that deleted file. Because yeah, maybe the capacity of the pool thinks it's only this full now, but I still have a point in time copy, or capture is a better word than copy, sorry. A point in time capture of when I didn't delete that file. So it still consumes the space there. So my point of what I'm saying here is you can keep your data forever if it doesn't change much. So setting your retention policy really will matter on how much your data changes. So it is good practice to not keep all your snapshots because again, actually not again because I didn't say this and I should have said this earlier, snapshots alone are not a backup policy. We'll get into later in one of the later perils how it is how it's part of a good backup policy. But if you truly want to keep something forever, you should make a copy of it and send it somewhere else. Anyway, I've gone on about that enough. Let's set a retention policy of 5, no, we'll say 7 days. So we'll keep a week and we'll rotate it through. So now let's hit add task. And now we want to schedule it. And again, I want to take a daily snapshot. So what I'm going to do is every day at midnight, I'm going to take a snapshot of my data. And then after 7 days, the task scheduler here will start to prune out old ones. So you can think of it as kind of like a rolling window into your data. So we'll save that interval. Now we're going to save that schedule. And now we're ready to go. We now have scrubs running, automated scrubs, and we have automated snapshots running so we can go and retrieve data should we need to. So 2 more perils down, a couple more to go.